Hi, my name is Noikam Basmin. My metric number is 191029. Me and my team going to present about the position control of servo motor using fuzzy logic. What is servo motor? Servo motor is an electrical device that can push rotate the object with great precision. If you want to rotate the object at some specific angle and distance, it is just made of simple motor which run through servo mechanism. If motor use DC power, it's called DC servo. If AC, it calls AC motor. The mechanism, it has three mechanisms, which is control device, output sensor, and feedback system. It is a closed loop system where it uses positive feedback to control motion and final position of shaft. Here, the distance controlled by a feedback signal generated by comparing output signal and reference input general. The application of the servo motor that being used widely is they are being used mainly in applications like toy, cars, helicopters, and robot. Last but not least is the problem statement. Before this, we use PID control. Sometimes cannot accurate for the application because of the non-linearity properties. So because of that, we propose to overcome the problem by using the fuzzy logic, because it has the ability to control the non-linear system because of the algorithm is constructed by simulating the expert and implemented the language.
So, hello, my name is Mohammed Jamal and I'm going to take it from here. I'm going to talk about the fuzzy logic, but let's introduce first traditional logic, which is it can be either true or false, which is between 1 and 0. But in fuzzy logic, as you can see here, it can be between 1 and 0, which is can be 0.7 in true, or false, which is can be 0.3. So in this example, which is water temperature, as you can see, this is a traditional logic. In this one, you might have either cold water or hot water. So in your system, it might have like true 1 and false, which is 0. So only cold water and hot water. And for fuzzy logic, you can change your temperature of the water by because as I said, the fuzzy logic, it's between 1 to 0, so you can have like slightly warm, cold water, like warm water, slightly cold, slightly hot. So you can there is a gradient between hot and cold. And this one, which is car braking system, as you can see, if with traditional logic, either you have to stop or you have to continue your way. But if you're using fuzzy control, you have like make your decision, because it's going to be between 1 and 0, so you can like take like have a break, and you can slightly slow down with the fuzzy control. Thank you.
Hello, my name is Chen Zhengjun and my metric number is ES02377. Now I will explain the transfer function for each component for our servo motor system. After my group members' introduction, we have learned about the servo motor system. As we can see in this picture, the transfer function of the servo motor system can be obtained as equal theta mt over EAT is equal to KT over GMRA S squared plus SBRA plus KT KB. And through the information, we know the parameters for use servo motors are KT is equal to KB is equal to 0.121, and the RA is equal to 2.23, and the KP is equal to 15, while KR is equal to 5, KD is equal to 0.5. Thus, by submitting these values into the equation, the transfer function of the servo motor system is as follows: theta mt over theta EA is equal to 863.19 over s squared plus 105.58s. And now we can see the transfer function of the PID controller. It can be as follows: Ks is equal to KTD over S and S squared plus 1 over TDI plus KTD over TD and TI.
Hi, my name is Ahmad Pranay Muhammad. I'm matrix number 191081. So today I will tell about the process. As we know, the PID control have been used, so we approach the fuzzy logic controller. So by that, we try to the fuzzy logic controller in there. So inclusion of the fuzzy logic creates many extra design problem. So the approach here is based on the 3-step design procedure. The first one, we start with a PID controller, and then second one, insert an equivalent linear fuzzy controller, and the third one, make it gradually non-linear. So it involves the three step for developing a fuzzy control. The first one, fuzzification, and the second one, fuzzy rule evaluation, and the third one, fuzzification. So the fuzzification is actually the inputs are categorized linguistically, and the second one, the fuzzy rule evaluation, actually the linguistic impacts are related to outputs, and the third one, the differentiation, which is the different outputs are combined produce a single output. So here the PID simulating diagram, and here the fuzzy simulating diagram, and this is the result. And for the conclusion, we found out the fuzzy logic controller is better for positioning control of the servo motor, so which is it better in the overshoot, oscillation, and settling time. By that, you also have the limitation of the fuzzy logic, which is a difficulty in predicting the stability, also the robustness of the system. That's all.